Hi folks, this is the 15th problem of the DSA series. So let's get started. Minimum window substring. Okay. So here we go. Given two strings S and T, return the shortest substring of S such that every character in T, including duplicates, is present in the substring. If such a substring does not exist, return an empty string. Okay, so what does it mean is, this is in a string XYZ. See if this string is present in this as a substring. Is it directly XYZ is not present, but if you see the substring YXAZ, this substring consists of all the characters present in this string, right? Hence this is the answer. Although we could have said, okay, this might be the answer, ZODYX. Here we also have ZYX, which is the substring, which is all the characters present in this string. However, the length of this substring is 5 and the length of this substring is 4. That's why we return YXAZ, which is the smallest substring, right? It says no, return the shortest substring of S such that every character in T, including duplicates, is present in the substring, right? Every character in T is present in the substring that we return, right, including duplicates, and this substring should be the smallest one, right? So this is what we ought to do. Now let's take another example. S is XYZ, T is XYZ, so it will return this XYZ only, right? This is the only possible thing. Here S is X and T is XY. We cannot find XY in this because obviously as S is of smaller length as compared to T, that's why we return an empty string as said here, as told here, right? So we have to return the shortest substring of S such that every character in T, including duplicates, right? That is, if we had this XXYZ, then XXYZ is not present here and we would have returned what? An empty substring, this, right? However, if this is the string, then we could have returned this YXAZVX, because X comes twice, Y and Z come once here. So we could have written that in that case, right? Understood? So we have to return the shortest substring of S such that every character in T, including duplicates, is present in the substring. Okay. So I hope you understood what we got to do. Now let's just go ahead and do it. So again, this is a problem of minimum window, not minimum, but this sliding window problem, right? So I'll make you understand as we go ahead, right? So this is string S, this is string T. Now first we can simply do this. If obviously S dot length is smaller than T dot length, then obviously the string T won't be present in the string S, because yeah, obviously S is smaller length. We could return this, right? If this is in the case, then what to do? Then again we'll do sliding window thing, right? First we'll take this, then we take this. Okay, is from S, first we take first character. Is XYZ present here? No. Is here? No. Is here? No. Okay, Z is present here. Okay, is here? No. Is here? No. Like we want whole XYZ thing. Is here? Okay, so XYZ is now present here. Now let's move from left side. Okay, so now move from left. Okay, is XYZ still present? Okay, still present. Now leave U. Is XYZ still present? Yes, still present. Now leave Z. Is XYZ still? No, it's not present. So this is the one substring that we get, right? We'll store this and its length. Okay, but we have to check till the end, because who knows, we might have found a smaller substring as we go ahead, right? So now we check this. Okay, then we move one step ahead, because it's XYZ is not present. Now XYZ is present. Okay, so now we move from left. OUZODYXAZ. Now we move from left. So this is XYZ still present? Okay, still present. Now let's move one step more from left. Is XYZ still present? Now move one step more from left. Now is XYZ present? No, it's not present. So we store this substring, right? And now whichever is the smallest substring will return that, right? So the core concept is first move to the right side. However, if you see that the needed substring is present in needed string, that is the string t is present in the substring, then simply stop and start moving from left, right, until the whole substring is not present, the condition is false, right? So yeah, and in this way move ahead, then again start moving from right, then if it's present then start moving from left, and so on. You will understand it better when I do it. Okay, so let's have let left is equals to 0, let result is equals to empty substring for now. Let let's take minimum length, because we got a return the minimum length substring. For now, take the minimum length infinity. Yes, we can do that. And in order to have track of what is it in this, like it can be this, right, we'll make a map, or you can say an object, which like x equals to 2, y 1, z1, right? In this case x1, y1, z1, like this. So let's call it, because we got to compare, right, this map to like to this, or to this, to this, to this, to this, right? Like we have to compare x1, y1, z1. Is the same case here, x1, y1, z1 in this map? If this is the case, then okay, that's okay. Okay, this is what we got to do. You'll understand it better as we proceed. So let's say let's call it t map. For this t, let's call it t map, empty map, and let's have another map called s map. S map will keep on changing, t map will be constant, because this is the t map, this will make up of t map. S map will be based on the substring that we are working on in the current iteration, right? In some time it might be this, where O1 U1 Z1, sometimes it might be this O2 U1 Z1, and this maybe this. So yeah, so S map keeps on changing, t map will be constant, because yeah, string is the constant thing, because yeah, this is not changing, right? This is what we gotta find. So now first let's make t map. For that we can simply say for let car of what, t. Here you can simply say t map, if car is already present in the t map, then do what? Simply increment its value by 1. However, what if it's not present? Then it is undefined, so instead of undefined, make it 0 and then increment it by 1. Okay, do this. So by doing this, we'll get the object or map t map. Now we'll loop over the s, the string s, to see which substring contains all the characters of t map, right? Yeah, to do that, let's have another variable called matches. Initially let's have matches at 0. I'll make you understand shortly what it is. Right equals to 0, right should be smaller than s dot length, because we got to iterate till the end, and then right plus plus. Now so the matches will be this. So here the t map will make something like this: x1 y1 z1. So here there are 3 matches, right? So these 3 matches should be found in here, right? This is 1 match, this is 2 match, this is 3 match. If x equals to 2, there might be 2 x's here, right? Still there are 3 matches, and it should be, there is 3 key value pairs that should be found in a particular substring that we take at a particular moment. That is, let's say we took this substring, then x should be 2, y should be 1, z should be 1. Then only the perfect match will be considered, right? It doesn't matter if we have another characters as well, right? For example, we could have like o equals to 1, d1, it doesn't matter. But if in this substring we have x2, y1, z1, then it's a match. Okay, right? For example, if we even take this answer, right, here we'll see x1, let's call this, okay, if we take this, we'll see x1, y1, z1 and a1. Doesn't matter if a is there, we understood that we have found our 3 required matches, so we are good to go. Okay, so yeah, that is what the concept of matches is. Now here, what should we do? We will simply check we could simply do right car is equals to s right, and then we can check we can do this. Yeah, yes, we can do this. We can say if in s map right car is already present, then in the s map simply add 1 in the right car, right? This is what we got to do, because right is incremented by 1, so we got to do this. Okay, however, we also need to check this. If t map right car exists, if it exists, and after increment that happened just here, t map right car is equals to s map right car, that means a match is being found, a key value pair match is being found in s map, which matches the one in t map, right? So we'll increment matches by 1. Okay, now we need one more while loop. Here what we'll do is we'll simply check, right? What should we check? If match is equals to, so what should the matches should be equals to in order to be a success? In this case, matches should be equals to 3, right? Even if x is being repeated twice, we had this, matches should be equals to 3, right? That is, matches should always be equals to the number of keys. Okay, so in order to be a success, so if matches is equals to object dot keys t map, then do something, right? Then say const left car is equals to s left. However, before that, since matches is equal to this, that means this is a success. So in this, the success, what I mean is all the characters that are present in the string t are present in the current substring s. Okay, the only thing we need to do is check the min length. If this is the minimum length, then make it equals to result, this particular substring, right? So let's do it. So we'll check if so matches is there, right? This is a success. This is a success means all the characters that are present in this string are present in the substring that we took, right? Only then the matches will be equals to this. Okay, so here we'll check if this is the case, then do what? If match is equals to object dot keys, then check the min length, right? Min length should be right minus left, and we got to add 1 here, right? If sorry, if this is smaller, this is smaller than min length, right? Because yeah, why we added 1, because right is included. If we do right minus left, right is not included in the length, that's why we got to add 1. Yeah, if this is smaller than min length, then simply say min length is equals to right minus left plus 1, and min length is equals to this, right, and do result is equals to s dot substring left right plus 1, because substring doesn't include this index, right? So yeah, we got to add 1 here to include right. So yeah, so this is what we got to do. And obviously in the end, after this for loop ends, will return the result. Okay, however, now here we are moving towards right, like this loop is making us move towards right, one step at a time, right? This is sliding window. Now we got to decrement the window from left as well, correct? So for that, what we'll do, we have this s left is this. Now we got to check. This we can do, but this we can do later. But we got to check if this match is happening. So let's see. So we got to check. We got to do this actually. So if actually this left car is present in T map, and the T map left car is equals to S map left car, that means it was present. Now we got to do matches minus. Why? Because here we are leaving out that left character from the sliding window, from our sliding window, right? So that's why initially it was present, right? Now, but still we got to do matches minus, decrement 1 from matches, because we are moving our left side, the left panel of our window ahead, right? Left plus and also S map left minus, right? Matches is also decremented, and there was this left in S map, not left, actually left car in S map, which we got to decrement as well. So this will keep on happening until we found the match is there, right? So it will keep on happening in this case because XYZ is present. Then OU, then will remove O, then it will do with UZODYX. Okay, this is still a match. Then we want smaller match, then we say ZODYX and so on, right? And in the next, and then we got a decrement level until this match thing, this condition is false, right? So yeah, in this way we'll get the smallest match, like the match with the smallest length. However, let's first see if it's working. Only after that I'll tell you the space and time complexity, because what if it doesn't work for some reason, right? So yeah, let's do const t. Okay, let's give it what min window st. Awesome, nothing came out. Okay, this is if. Then we had the left car is correct. Here we had right car. Do matches minus. If this is equals, like exactly equal, then matches minus. What the heck we are doing wrong here? Min length is there, and then s dot substring. Yep. So let's just console the result here every time we get some result, just to debug the shit. I'm not even able to write the spelling result. Okay, let's see. Awesome, nothing is getting printed. Why? So let me just console log. I think I'm making some stupid mistake. It is coming. Am I even getting into this loop? Right, plus plus. Okay, console log dun. Yeah, yep, the loop is running. Matches plus plus, matches minus minus, matches equals to 0. Okay, object dot keys dot length. No, yep. Now it should work. Right, result is XYZ. See, it gave me every result. Here we have ZYX. However, so it takes, okay, so matches is there, like all ZYX is found, but we gotta remove this shit from left, so it removed from left. Then again run this in another loop, still the matches is there. Then it remove U, then still the matches is there. Then it removes it, then matches is not there. So it comes to this outer loop, right? So in this way, in the end, we'll get this YXAZ. Let me remove the console, the inner console. Okay. Now, since this is working, let me tell you what is the time complexity. Time complexity is O of, you tell me, this is the sliding window, and here we are looping over this only once, right? This inner loop doesn't consider, because here only we are just removing element from the left side. That's all we are doing, right? So this plus this doesn't matter. It's O of n. Like we are iterating over the whole thing only once. So O of n is the time complexity. Now what is space complexity? Space complexity is O of what? So here we are taking this T map and S map, which are actually taking space. This is constant. These are actually taking space, but one thing you saw here, it says SNT consists of uppercase and lowercase English letters. So it doesn't matter like how much space it can take. There are 26 letters in uppercase, 26 letters in lowercase. So 52 letters are there. Here on also 52 are there. So yeah, so it is O of 1, because this is 52 is a constant, right? The space complexity is O of 1, time complexity is O of n. That's all from my side. Yep, thanks for watching.